Okay, in this problem we have a flywheel that rotates about a fixed axis of a steam engine. It is rotating at a speed of 600 RPM before a brake begins decelerating it with a constant deceleration rate of 30 radians per second squared. One thing we're interested in is the time required to bring it to a complete stop. We're also interested in knowing how many revolutions does the flywheel go through while decelerating. Observe that the given speed can be taken as the initial speed omega 0 equal to 600 RPM. And I want to convert this to primary units of radians per second, so I multiply by 2 pi divide by 60 and get a numerical value of 62.83 rads per second. The given acceleration is constant and it is slowing down, therefore it's actually a deceleration or negative 30 radians per second squared. And again, because the acceleration is constant, I can use kinematic equations for constant acceleration. Recall they are theta equal to theta 0 plus omega 0 t plus 1/2 alpha t squared. The speed equation is omega equal to omega 0 plus alpha t. And recall there is a third equation which is independent of time, and that is omega squared equals to omega naught squared plus 2 alpha delta theta. So as far as finding the time required to bring it to a complete stop, I can use this equation which has only one unknown t. Final speed is 0. Initial speed is 62.83 plus, or in this case minus 30t. So I have an equation with only one unknown t. I can solve for it and divide 62.83 by 30 and get a numerical value of 2.09 seconds. So this is one unknown. Okay, so I have this time, and then as far as the number of revolutions are concerned, since I have one unknown, I can use this equation which is theta. I have the final speed of 0. Initial speed is 62.83 squared minus 2 times 30 times delta theta. Solving this for the number of revolutions, I get a numerical value of 65.8. This is in radians. To get it in revolutions, I multiply by 1 rev equal to 2 pi rads. Rads cancel, and if I take a calculator and divide, I get 10.5 revolutions.